Okay, good day everybody. Today we're going to talk about alchemy and how it uh, contribute to the development of the modern chemistry. So first, what is alchemy? Let us define alchemy. Alchemy is a pseudoscience. When we say pseudoscience, these are practices or uh, views or beliefs that were assumed to be science, where in fact they are not if we are going to compare it with scientific method. So that is pseudoscience. Alchemy is a pseudoscience. It used Egyptian techniques of handling materials to scrutinize theories concerned with nature of matter. These techniques include distillation, crystallization, and sublimation. People who adhere and perform alchemical works are termed alchemists. So, alchemy in earlier times, they have already uh, discovered the techniques distillation, crystallization, and sublimation. Distillation, crystallization, uh, and sublimation, these techniques are still in use in the modern times in the in modern chemistry, especially distillation. It can be used to extract substances from materials, just like for example the extraction of essential oils from flowers, the separation of non-volatile and volatile mixture. When we say volatile, a substance is said to be volatile when it readily evaporates in a given condition. For example, water evaporates at 100 degrees Celsius, starts to vaporize. It is the boiling point of water. Therefore, at that instant or at that moment, or at that condition, water is said to be volatile. So, crystallization, uh, I think it is another term for solidification. Then, sublimation is a process in which a solid substance directly change its phase into gaseous phase. So, that is sublimation. So, there are people who are referred to as alchemists uh, during the alchemy uh, period. They are in the modern times. We have what we call chemists. They practice the theories, the laws, and concepts in chemistry. They primarily work in laboratory. So in alchemy, they have alchemists. A common interest among alchemists was that to transform base metals like iron and lead into gold. This was known as transmutation. This was said to occur in nature and can also be brought about by means of a very small quantity of a powerful transmuting agent called the philosopher's stone. So there is a very popular belief or a concept among alchemists that was to transform base metals like iron and lead into um, precious metals like gold. They said that this transmutation is a process that occurs in nature. Gold is a perfect state. Base metals like iron and lead are will eventually reach that perfect state, which is gold, that occurs naturally, and it can also be brought by means of a very small quantity of powerful transmuting agent. So it can also be done by uh, humans, that is to transform base metals into precious metals like gold by the use of a powerful transmuting agent, which was later called as the philosopher's stone. So let me put an emphasis on the distillation. So this is the setup, laboratory setup of a distillation in modern chemistry. Okay, so let's see how it works. For example, if we have a mixture of, uh, let's say we have a mixture of salt, have a mixture of salt and water. So salt, which is solid, we have table salt, the NaCl. If we put that in water, they will form a homogeneous solution. The salt will be dissolved in water. The salt will be dissolved in water, forming a solution, homogeneous solution. When we say homogeneous solution, the phase or the characteristic of the uh, solution is uniform all throughout. So for example, its color, no, its phase is uniform all throughout. We can see it just by uh, the unaided eye. Okay, so it forms a solution. What if we are uh, concerned of using salt and using water? How are we going to separate the two when the salt is already dissolved and what in water? So uh, what we do is we distill the solution. The solution is a salt water solution in this case. So distillation uh, is primarily based on the volatility of a substance and its boiling point. So first, we have to determine the boiling point of the volatile substance. So at any condition, salt will not evaporate. For example, if this thermometer is from 0 degree to 250 degrees Celsius, even if it will reach 250 degrees Celsius, salt will not evaporate. Thus, it is non-volatile. However, water is a volatile substance when it reach or it readily vaporizes at 100 degrees Celsius. When the temperature rises and reach 100 degrees Celsius, water molecules will start to evaporate because that is the boiling point of water. So, if we have a saltwater solution and we subjected it to a heat source, then we will just wait until the mixture will or the solution will boil. Okay, no? So, as it boils, we have to observe at the temperature. So, as the temperature rises, the more water molecules will vaporize. So as it reach 100 degrees Celsius, let's say dito yung 100 degrees Celsius, which is the boiling point of water, then these water molecules will start to vaporize and vaporize and vaporize. So those water vapor is a term used to denote water vapor is a term used to denote the gaseous form of a liquid, no? So if in given condition it is liquid, then its gaseous phase or gaseous form is called a vapor. So water is liquid in normal condition. So when it vaporizes, it is called uh, water vapor, its gaseous form. So that's it. So water vapor will follow this path until it reach our condenser. So this is a condenser. It has the inlet tubing here, the inlet pipe. The tap water or cold water will pass through here. Ito pala ipaikot. Then it will eventually go out here. It will exit here. So this is a cold water. It is not boiled, or it is a tap water. So this water vapor acquired heat. That is why they vaporize. They vaporized. So here, as they pass through the condenser, this is called a condenser. This one, that is a condenser. As the water vapor passes through the condenser, the water vapor, the molecules of water vapor are being uh, cooled. They are being cooled, no? So here, the temperature is lower. So as the condenser cools the water vapor, it and as the water is running through the condenser, the water vapor will go back to its original state, which is in liquid form. So kapag nakabalik na siya sa liquid form, then it will run through here, and it will then be collected in a container like this. This is a graduated cylinder. It will be collected here. So this condensed water vapor and then collected by the graduated cylinder, they are called distillate. The substances that are collected here that undergo the process of distillation are called distillate. So the remaining substance here in our boiling flask here are called residues. So that's how distillation works, and it is very important, and it is still being used until today during the period of modern chemistry. So that's all. Then let's move. So alchemy also has a branch uh, which dealt with medicine, and it rose in the 16th and 17th century. Alchemy lasted until 17th century. The theories and attitude of alchemists were gradually questioned. The notable work of Robert Boyle, the skeptical chemist, 1661, criticized alchemical thoughts. Furthermore, Boyle put an emphasis on the idea that chemical theory should be based according to experimental evidence. So, since alchemy is just based on assumptions, on philosophical views, on philosophical assumptions, or based on practices without experimental evidence, then that is why alchemy is considered as pseudoscience, because it most of the alchemical thoughts did not undergo experimental or don't have experimental evidence. They are just assumptions. So as time goes by, there are some people who started to question the alchemical thoughts, and one of them is Robert Boyle. Although Robert Boyle believed that base metals can be transformed or can be transmuted into into gold or precious metals like gold. Uh, the term transmutation is still being used today in modern chemistry, especially in nuclear chemistry. So, when a nuclei undergo a nuclear reaction and uh, it transformed into another nuclei, let's say, for example, we have oxygen, tapos naging nitrogen siya, nuclei, naging oxygen nuclei, naging nitrogen nuclei, then that is called transmutation. So in nuclear chemistry, the term transmutation is still in use today. So that's it. Let's move. So after the domination of alchemy, there is another theory that conquered the world of chemistry. It was called the phlogiston theory from 1650 to 1790. Phlogiston was believed to be a constituent of any substance that could undergo combustion. This theory was the work of George Ernst Stahl. So after the alchemy, there is another that followed it, which is the phlogiston theory. Any substance that can be burned has a phlogiston. So any material that can be burned or that can undergo combustion, it has a phlogiston. It is a constituent of any substance that could undergo combustion. However, after the phlogiston theory, modern chemistry has followed after. But in modern chemistry, which was regarded to which was regarded uh, to be or is believed to have started because of Antoine Lavoisier's work. Antoine Lavoisier's work was regarded as the beginning of the modern chemistry. He disproved the phlogiston theory and was the one who proposed the law of conservation of mass. Law of conservation of mass states that the mass of the reactants is equal to the mass of the products. So why is that the mass of the reactants is equal to the product? So actually, Antoine Lavoisier made an experiment. So he made an experiment like he burned a substance, but before he burned the substance, he measured the mass of it. And after burning, he measured also the mass of it. So that after getting both masses, he observed that the masses after and before and after the combustion was the same, and there was no detectable change in mass between the reactants and the products. So he uh, proposed that the mass of the reactants must be equal or is equal to the products, since there is no detectable change all throughout the combustion. So since there is no detectable change, so the masses must be equal. So that is the reason or one of the bases that we balance a chemical equation because of this law. Okay, during an ordinary chemical reaction, let us look, for example, the formation of H2O of the compound water. So when you see subscripts like this one, so subscripts, this means in gas. This denotes their state of matter. They denotes the phase of the matter. So when you see this G in a parenthesis, small letter G, that means in gas phase. When you see this subscript, a small letter L in a parenthesis, then that means in liquid phase. If you see S within parenthesis or parenthesis, then that means the matter or substance is in solid form or solid state. If you see a Q, that means the substance is an aqueous solution, meaning it dissolved in water. So that's it. So let's inspect this chemical equation. So as you can see, hydrogen with a set of properties which is, let us take for example, hydrogen is a combustible matter or material, combustible substance. Then hydrogen reacts with oxygen to form or yield uh, water or H2O compound. So as we can see, the element present or substances that constitute the compound present are the same with the elements or substances in the reactants. So we can see here that only the arrangement changes. So in an ordinary chemical reaction, atoms break bonds and then rearrange. After rearranging, they form new bonds, thus resulting to a new or forming to a new substance with new set of properties. Just like this H2O, water is non-combustible and can be consumed by humans, while hydrogen, one of its constituent elements, is highly combustible. So there is now a new property, new substance with new properties, which are completely different to its constituent elements. So that is uh, that is what happened when atoms rearrange and form new bonds. So this is what happens in an ordinary chemical reaction. Then since atoms just rearrange, they break bonds and they form new bonds, we can say that since the elements are still the same, we can say that there are no new atoms created nor old ones are destroyed. So therefore, we can also say that the masses should be the same and equal. So, ayan, no? We have, as you can see, there are uh, there are the same elements present. So here, if we have H2O without coefficient, these are coefficient, these colored numbers in front of the chemical formula. These are coefficient. They are there, they are used, or they are placed there to balance the chemical equation. So O plus, no, sorry. This must be H. For example, if you are given H2 plus O2, let us disregard first their state of matter, then H2O. This is an unbalanced equation. We have to check, for example, the number of H atoms and oxygen atoms in the reactants. Here, this side is reactant side, here, here, and this is the product side here. So we have to check whether they are balanced. So here, if there is no 2, number 2, hydrogen is 2, and here hydrogen is 2. So we can say that is balanced. However, uh, the oxygen is 2 here, but 1 in the reactant side, in the product side. So we have to balance the equation. So we have to put a coefficient. We have to put coefficient for us to get a balanced chemical equation. So what do we do? So what we do is, for example, since we put coefficient here, so we put coefficient here. So now, if we are going to multiply it by 2, 2 times 2, that will become 4 hydrogen atoms. Here, 2 moles times 2 atoms, that will become 4. Then oxygen, there are 2 oxygen, then there are also 2 oxygen. Okay, so if the number of atoms from left to right, or from the reactant side and product side, if they are equal, then we can say that the equation is a balanced equation. Okay, so if they are not balanced, or if the number of atoms are not the same or are not equal, then the equation is an unbalanced equation. So let's check on the mass. So the mass of a hydrogen is 1 atomic mass unit. No? 1 atomic mass unit. Atomic mass unit is a unit used to measure the mass, used in determining or measuring the mass of an atom. So it is in atomic level and molecular level. So that's it. If we are referring to moles, then we use gram. But here, let us use atomic mass units, atomic level. So hydrogen has one AMU, or atomic mass unit, and oxygen has approximately 16 atomic mass unit, has a mass, or has a weight of 16 AMU. Okay, so since there are already 2 atoms of hydrogen, then that is 2 times 1, that will become 2. So kaya 2 siya dito. Then there are 2 moles of diatomic hydrogen, then that would be, or that will become 4. Okay, so since there are 2 atoms of oxygen and it has a mass of 16 atomic mass units, 2 times 16. Okay, get your calculator. Let us see if the answer is correct. 16 times 2, that is 32. Okay, plus 32. 32. 32 plus 4, that is 36. Okay. So here, the same concept, or the same method, hydrogen has 1, 2 times 1, that is 2, times 2, that is 4, plus oxygen has 16, no? There is only one oxygen here, 16, but there are 2 moles of the ano water, or the or water compound, or the compound water. So that is 2 times 16, 32. 32 plus 4, that is 36 atomic mass units. So the masses are equal. Therefore, this is balance and adhere to the law of conservation of mass. So that's it. Moreover, I'd like to ask, what is the difference between this 2H and H2? What is the difference of that? Uh, okay. So here it indicates mole, the coefficient. There are 2 moles. And 1 mole is equal to 1.6022 times 10 raised to 23 particles. That particle can be ions, atoms, or molecules. So that's it. The difference between 2H and H2, also, this one is bonded to uh, another hydrogen, meaning there is a bond between this between these atoms. There is a bond, chemical bond. While here it indicates individual atoms. Done. Done. Okay, so that's it. Then there are 2 of it, so that's why. Okay, so let's have a quiz. So this is a 10 point 10 point quiz, no? So this is a 10-point quiz, meaning each has each item has a 1 point. Then there are 10 items, so there are a total of 10 points. There is a total of 10 points. So that is a 10-point quiz. So just answer this one. You can pause this video to answer this one. And later, I'll be revealing the answer. It's up to you if you are going to pause this one. Okay, I'll give you 5 seconds to pause this one because I am going to reveal the answer. 5, 4, 3, 2, 1. Okay, next. So here are the answers. So, ilan ang nakuha niyong score? Did you get 10 over 10? Perfect score? Or only one mistake? So, I hope you've done well. Okay. So, let's proceed to this so this channel. So what is the connection of the name of this channel to this topic, alchemy? Okay. Let me inform everybody that I am currently studying. I am still a student. I am just sharing what I learned from the references I have used to learn chemistry. Since I am still on the process of becoming a professional, I can say that I am an alchemist. Just like alchemist, it was still alchemy is a premature. No, it was premature, while chemistry is mature. So since I am still a student, I think I am still there are still knowledge that are uh, there are still information or knowledge that are lacking to me, and I have to learn that, especially the higher concepts. No, I have to learn those one. That's why I am therefore I named this channel Alchemist, referring to myself. The books and other references I used are acknowledged along with the authors and are all shown in all of my videos. So here is our reference. I've used the Chemistry 6th edition of Charles Mortimer, which was published in 1986 and was published by Wadsworth Publishing Company in Belmont, California. So the image that I used to represent the distillation a while ago, the simple distillation is from the, let's go back, it's from the Pixabay. So let's give thanks to Pixabay. So it is a free copyright site for images. So you can get images there for free and use it in your presentation. So that's all. Thank you. I hope you have learned uh, from this video, and I hope you don't forget to like this video, subscribe to my channel, and share this video. That's all. Thank you. I hope you are doing good.